because it cuts away the low, and the word cut is not a really nice word in Dutch. So that's why they decided to make it a high pass filter. Hey guys, today we've got coffee. It's almost empty, so that's not a good sign, but well, who cares? A lot of guys have asked me to make this video, a bit more in-depth video about an audio engineering basics thing, and that is EQing. First of all, we need to understand the term EQing and what it means. EQ is short for equalizer. Equalizing is nothing more than making things flat. You can also equalize concrete. You are building a floor, you can equalize the concrete. And the same goes for audio. We want to equalize all the frequencies. So we want to make sure that everything is in a certain shape. I say shape because people want to have it flat, like the lows need to be as loud as the highs. That only gives a really dull, boring, transparent sound. You are actually shaping it and coloring it. EQs are also one of the most used tools in the studio together with compressors. I personally really love to play around with EQs. You can see my big black box with silver buttons over there, which is also a sort of EQ. I've got more analog stuff over there. I built them all by myself. They are my own design. Different EQs also sound different. Maybe I can make a video about how every different EQ sounds if I have time. So that will be somewhere later. If I have this video done, I will link it somewhere in the corner. So let's dive into this. There are 3 buttons on an EQ which are really important. We've got the Q, frequency, and gain. So the gain button is pretty straightforward. Just as a preamp, you can give more or less gain to something. And in this case, this something is a band of audio. If the full audio range is from 20 to 20 kilohertz, a band can be whatever you set it to. So for instance, a band can be from 1 kilohertz to 2 kilohertz. That's the band. That's also what you decide with the frequency button. And I can show you this because when I pull up the gain, we can see over here, it will make a peak and it will gradually move down until it's back at 0. So an EQ always goes like this. It won't, lift up the band like this. I'll come back to that later. So the width of this band is being determined by the Q factor. And on modern day EQs, the Q factor is something you can adjust. But back in the days, the Q factor stood for quality factor. The better an EQ was designed, the higher the Q factor was, and the smaller the band was, it was EQing. So it went from a really broad band, which was really simple to make. It's like a resistor and a but still this number is still a bit strange. You've got a Q factor of 1 or 2 or 40 or 0.5. So rule of thumb for this is a Q factor of 1.4 is 1 octave wide, and a Q factor of 0.7 is 2 octaves wide. Something like that. An octave is nothing more than doubling a frequency. So an octave of 500 hertz, the first octave is 1 kilohertz, so 1000 hertz. An octave of 1000 hertz is 2000 hertz. If we have 1 kilohertz frequency set like this, and we go to 1.4, you can see that roughly around 500 hertz, it's back at 0. It's a little bit. Same goes roughly around 2 kilohertz over here. It will be done back. Not a really good representation, but that goes for the basic buttons on the EQ. So these 3 buttons are what you control with an EQ. But we are not finished, because this is the most simplest EQ there is. But there are also other forms and shapes of EQing, and EQing goes side by side with filtering. So let's walk through all these buttons over here. So we've got a high pass filter. They say high pass because it cuts away the low, and the word cut is not a really nice word in Dutch. So that's why they decided to make it a high pass filter. As you can see, it will cut away everything below the frequency we have set. Right now I've set 1 kilohertz. I can also go down and cut away only like low frequencies. There's also a Q factor involved in this, and this is also about the quality of the filter. The better the filter, the steeper it can cut. Well, I can just show it to you by pulling it down. You can see that it will get less steep or really, really, really steep. So the steepness is also with octaves and decibels. It says how much dBs are dropping off per octave. So if we go to 1 kilohertz, 500 hertz, which is an octave lower, will be 24 dBs quieter. And when we go another octave lower, which is 250 hertz, it will again be 24 dBs lower. And when we go another octave lower, which is 125 hertz, it will be again 24 dBs lower in volume. And until it's so quiet that it's somewhere in the noise floor. Well, how does it sound? Well, it sounds a bit awful, but this is what it sounds. It sounds like a small transistor radio because a small speaker in a transistor radio also cannot reproduce the low frequencies. And when we, you can hear it becoming richer because there are more low frequencies in there. So that's a really important thing to understand when you want to cut away some low end. I see a lot of people cutting away like 20 or 30 or 40 hertz on their master bus to get more headroom, which is really cool. But since it's a low frequency, we don't have that much octaves before we are, out of there. So the lower the frequency you have, the steeper the filter has to be in order to really cut it away. So that's a high pass filter. Another one, a notch. And a notch filter is filtering out one frequency band. So the band I was talking about, which you can gain up and down, notch filter is, cutting it out and really cutting it out, like removing it at all. It also got a Q factor. It functions the same as on a normal bell EQ. You can cut out, really one frequency, which is very difficult to hear, or just a whole space of it. A hole in the recording, really a hole in the recording. So let's move on with shelving. And shelving is also interesting. What shelving actually does is pretty simple. It takes away one of the two sides. So as you can see, with a normal filter, it will cut out over here. So it will only do this small piece. With a shelving filter, you will get the whole smash. This comes really handy when you really need a lot of highs in there, which need to go from like 1 kilohertz till the end. Sounds like this. This again comes with a Q factor, and this time the Q factor is the slope of the shelf. So just like an EQ, you go lower, it will slope till almost like 50 hertz, and if you go up, it will go crazy. So we've got a high shelf. We also got a low shelf, which works the other way around. So a lot of low. This is really one of the worst sounding EQs I have, by the way. So, and the last one, so we had the peak or bell EQ, and the last one was low pass filter, which is the other way around of a high pass filter. So, and there are two more things I want to talk about, and I need a different EQ for it, and that's my beloved Fab filter. Still not being sponsored by them. Why should they sponsor me, by the way? And well, the first thing is that on analog equipment, on an analog EQ, like this one, doesn't have a Q factor setup. This one has got frequency, and I think it's a Q of 1 or maybe 2. I can modify it by soldering new capacitors in them. The Q factor moves with the gain, and that's really difficult to understand, but if you gain more, the Fab filter does really well in illustrating this. You have to enable this small button. When you turn up the gain, you can see, also check the Q factor, what it's doing. It's getting smaller and smaller. If we zoom out a bit, it will get a smaller EQ with a higher gain. If I disable it and put the Q factor back to 1, I'll be over there. So that's pretty cool. If you are, really working high gain on the filters, you don't want to have you don't want an extra 5 dB of 60 or 50 hertz. So it's pretty. That's a feature I love from analog equipment, and on my Pro Q, this button is almost, glued in. You cannot glue a digital button, but it's glued in. The Fab filter gives one more button, which we also know from a low pass and high pass filter, and they have also attached it to a EQ band. To a bell. And what it does, so the Q factor decides the width of it. This button decides if it needs to be really steep, like this, or if it can also be like this. And when we go to get a really straight band of EQing. Although I really like that Fab filter did this because it makes it very versatile. A lot of people mistake it for, I really want to cut that frequency space, but our ears aren't used to having like boxes. They like a gradual slope. You can hear it if I play it like this, or like this. This sounds much smoother than this sound. I really like these steep shelves only for doing small corrections or like, you know, really only for corrections, not for coloring. I think this video is long enough right now. I'll also do videos soon about the differences in sound. I've got a lot of different EQs. I've got a lot of different digital EQs, which all have the same character. And I also got a lot of different of these analog pieces. The rest is over here and it weighs 600 kilos, so I cannot. And they all have their different character. And I'm going to look for a way in which I can describe and let you hear it the best. So stay tuned for that. I will make another video about EQing myths, because there are a lot of magic myth tricks about EQing that starting producers and starting engineers get wrong, which I also got wrong until I started to use my ears and until I got more experience. So I really want to share those things, but this video is too long for this. I will make a separate video about that subject soon, when I have got time again. You can click the subscribe button over here and you can check out my other videos over there. So thanks for watching and I will see you next time. Bye bye.